Lesson 15:9 is about probability. So we're going to be finding the probability that an event will occur. You calculate probability with the formula you see there. The numerator is the observed number of times the event occurs over the total number of observed occurrences. So we'll talk about that more in just a second, and it'll make sense when you see an example. Probabilities, though, occur on a scale of 0, meaning it won't happen, it is impossible, up until 1. 1 is like 100% certain to occur. Obviously, then if you get a 1/2, then the probability of that event occurring is 50-50. So here's an example. What is the probability of rolling a pair of dice and getting a 7? So you see now what we did that lesson on sample space, so you could think about the total number of possibilities. So let's first look at the probability of rolling a 3. That's part A. So we want to think about the number of ways there are to roll a 3. So that would be if I roll a 2 and a 1 or a 1 and a 2. So there are 2 ways to get that specific event to occur out of a total number of 36 occurrences. So the probability is 2 over 36, or if we reduce, 1/18. Part B is the probability of rolling a 7. A 7 is actually the most probable number to roll when you roll 2 dice because there's so many ways of getting a 7. A 1 and a 6, a 2 and a 5, a 3 and a 4. And then all of those possibilities. So there's 6 ways out of a total 36. So the probability of rolling that is 1/6, which is much better than 1/18 for rolling a 3. Example 2, a package of tulips has 9 yellow and 3 red tulips. What is the probability of selecting 2 red? Okay, so this has a little bit more work here because it has to go back to when we talked about combinations. So if we think about the number of ways to choose 2 red, we have to remember that we're choosing from 3. So the total number of ways to choose 2 red is 3 choose 2. That, though, has to be over the total number of ways to just pick 2 from everything. So there's 12 total tulips, choose 2. So the numerator is the number of ways to pick 2 red. The denominator would be the number of ways to pick just 2 flowers in general. So the total number for the specific event over the total number of possibilities. Or in this case, the probability is 1 over 22. Let's try one of each. Well, in this case, we're still going to have the same denominator because we're still choosing 2 from a total of 12. But the numerator has to be specific to this event of choosing 1 of each. So let's think about the number of ways to choose 1 yellow. There's 9 total, we want 1. 9 choose 1. Then we can multiply that with the number of ways to choose 1 red. Well, there's 3 red, we want 1 of them. So if we multiply 9 choose 1 and 9 choose 3, we get 27, and our denominator is still 66. So the probability is 9 over 22. Example 3, a jar contains 4 watermelon, 6 grape, 5 apple, and 3 lemon Jolly Ranchers. You pick 3. What is the probability of choosing, let's do part A first, 3 watermelon? So for this actually for all 3 problems, we're choosing 3 Jolly Ranchers out of a total of 4, 6, 5, 3, so 18. So I'm going to go ahead and just write the denominators for all 3 of these problems actually. Each of them is going to be 18 choose 3 because there's 18 Jolly Ranchers and we're picking 3 of them for our total. Now the numerators will depend on what you're actually picking. So for the first one, you're picking 3 watermelon. Well, there's 4 total watermelon, so the number of ways to choose 3 watermelon is 4 choose 3. So that's 4 over 816, which is 1 out of 204. So our probability is 1/204. For part B, let's pick 2 grape and 1 apple. So to get 2 grape, there's 6 total grape, we want 2. We'll multiply that by, to get 1 apple, there's 5 apple, choose one of them. So if we multiply those numerators together, we'll get 75 over 816, and that's 25 over 272. And finally, 2 lemon, 1 grape. So there's 3 total lemon, we're going to take 2 of them. And then for grape, there's 6 total grape, we're going to choose 1. So then we'll have, for our numerator, it's 3, choose 2 is 3, times 6, so 18 for our numerator. So 18 over 816, which is 3 over 136. So we always want to reduce our fractions. Example 4, 5 cards are drawn at random from a deck of 52 cards. Find the probability of getting a pair of 6s, and then 3 of a kind, and then a flush. Okay, I'm going to go ahead and make all the denominators again, because in each of these cases we're taking 5 cards out of 52. So for each of our denominators we're going to have 52 choose 5. Okay, so let's do part A, pair of 6s. Now remember, we did a lot of practice with this in previous sessions. So if you have a pair of 6s, that means you have 2 6s and 3 not 6s, because you have a 5 total in your hand. So 2 6s, we would say, okay, well there's 4 of those 6s, and we want to choose 2 of them. And then we want to say choose 3 not 6s. So the number of cards that are not going to be a 6 are 48. So in that case, let me write our answer here. There it is. Let's do 3 of a kind. 3 of a kind, remember, you want to have 3 of the same card and then 2 that are not the same. But we don't know what kind it is. So it's 3 of the same kind, but it's unknown kind. It's not like I'm saying you get 3 aces or anything like that. So when we do our original, okay, there's 4 of each of the same kind of card, we're going to choose 3 of them. We're going to have to multiply that by 13, because we don't know if it's aces or kings or queens or jacks, etc. There's 13 different types of cards. Then to do our 2 that are not the same, we say, okay, we're choosing 2, and then there's going to be 48 that are not that same card. And that's the way to find the probability of 3 of a kind. Let me write the answer here. Okay, let's do the probability of a flush. Okay, a flush means that you're getting 5 cards of the same suit. So for each suit there are 13 cards, and we're going to choose 5 of them. But we don't know what suit it is. This didn't say a flush of diamonds or a flush of hearts or spades or clubs. So there's 4 different options for the type of flush it would be. So our probability here would be 5,148 over the same denominator. Let's do a couple more of these card examples. Let's do a full house. So here we're still drawing 5 cards from a deck of 52. So I'm going to go ahead and rewrite our denominators as being the same. Okay, so to get a full house, remember full house is 3 of a kind and 2 of a kind, of a different kind. So 3 of a kind and then a pair of something else. So let's do the 3 of a kind. So there's 4 cards of each type and we want 3 of them. But because we didn't say that you have 3 aces or 3 jacks or 3 kings, we didn't say what kind, you have to multiply that by the 13 kinds. Now let's do 2 of not that kind. So there's 4 cards of each kind, we're taking 2 of them, but we didn't say whether, again, this is an ace or a king or a queen. We don't know what kind it is. Now, there's 13 different kinds, but we don't want to use the same kind that we already did. So instead, we're going to multiply that by 12 because there's only 12 types left that that card could be. So with all that, we'll get our answer. Numerator is 3,744 over the same denominator because we're still have a 5-card hand. Okay, next one, let's do 2 aces and 1 jack. So this time we are specifying what the cards are. So we're not going to have that extra business of multiplying by 13 or 12 or anything like that. So 2 aces, we remember that there's 4 aces, we want 2 of them. Okay, then for 1 jack, we remember that there's 4 jacks and we want to choose 1 of them. Now, don't forget that you have to have 5 total cards in your hand, so what we're going to have is 3 not aces or jacks. So we're choosing 3 cards, and the number of cards that are not aces or jacks are 44. You would just subtract the 4 aces and the 4 jacks from the deck of 52. And so we do that work, and here's our solution. Okay, last one here with the cards. Let's do 3 spades, 2 hearts. So 3 spades, we think about how many spades there are. There are 13 spades and we want 3 of them. Done with that. 2 hearts, there's 13 hearts and we want 2 of them. And that's a total of 5 cards already in our hand. So that's it for that one. And we have our probability. Let's do a couple more card problems. Okay, so we're still drawing 5 cards from a deck of 52. So our denominator is still 52, 5. 52, choose 5. Okay, let's do 3 spades. So there are 13 spades and you want 3 of them. But don't forget you have 5 cards in your hand, so you have to think about the other 2 that are not spades. So 2 not spades. The number of cards that are not spades in a deck are 39, because you would just subtract the 13 from the 52. Let's do the next one here, 5 aces. So there aren't 5 aces in a deck. There is 0 probability of you getting 5 aces. We're just playing with a standard deck, no wild cards. So in that case, the probability is 0 because it's impossible to draw 5 aces. Same idea, we're drawing from a deck of 52. Let's try something a little bit more complicated here. So it's still 52, choose 5 in the denominator though. We're going to draw a king, a queen, a jack, and none of which are spades. Okay, so 1 king. So first of all, I know I'm choosing 1 card. And I want it just to be the king of hearts, the king of clubs, or the king of diamonds. So there's only 3 options there. And that'll be the same thing for the queen. If it can't be a spade, then there's only 3 options. And then if it's a jack, but it can't be a spade, there's only 3 options. Now don't forget, you still have to have 5 cards in your hand, so we got 2 more to do. So we don't want them to be spades. And so we have to subtract the number of spades, and we don't want any more kings, queens, or jacks in our hand because we're just supposed to have 1 king, 1 queen, 1 jack. So for this, we need to subtract out the spades and then the kings, queens, and jacks. So 30. And I'll leave that to you guys to calculate the probability. I'll just do the setup here. Okay, let's do at least 1 king. All right, at least. That always causes some extra work for us because the idea is that we could have 1 king, or we could have 2 kings, or we could have 3 kings, or we could have 4 kings. So what we're going to do is find the probability of each, and then we'll be able to sum them together. Okay, so I'll go ahead and just do this setup again and leave the calculation to you guys. So in each case, we're always choosing 5 cards from the deck. So just like we've done with all of these problems, we're going to have 52 choose 5 in our denominators. Okay, so then for the first one, we need to say the number of ways to choose one king. Well, there's 4 kings, and we want one of them. And then we want the rest of the 4 cards in our hands to not be kings. And there's 48 not kings. So that would be the probability of 1 king. 2 kings, we would have 4 kings, we're choosing 2 of them. And then we want 3 of the not kings. So you'll notice, the top number here, the 4 and the 48, are going to stay the same. The number of those that I'm choosing is changing. So if I have 3 kings, there's still 4 kings, but I want 3 this time. And there's still 48 not kings, and I want 2 of those. And then finally, 4 kings, I want all 4. And for the 48 not kings, I just need 1. So if I calculate each of those probabilities and sum them, I'll have the probability of at least 1 king. Okay, that was a lesson 15.9. Go ahead and check Schoology for homework.